One second. So, hi everyone. So, we have done with like project uh, explanation. Like here we're going to use SnowSQL or SQL, Snowflake, AWS3, DBT, ADF, blah. So, this is like completely data migration project, healthcare domain. So, workflow is we have files like CSV or JSON, Parquet, Avaro in different source system like Oracle, CRM, SQL Server from the hospital systems. So we're going to receive the files. So though like ETL team, they're going to push this data into the here in AWS S3. So thereafter, as a Snowflake developer, our process will start. So we need to load data into Snowflake into raw layer. Then after that, we need to connect with the DBT. Then again, it going to staging layer. So after that, final data, business logic, we're going to apply in curated layer. So this data going to used by the Power BI or any reporting tool. Okay, so we're going to have factor dimension tables. So we may be going to receive like tables like doctor, patient, visiting, so insurance tables, claims, payments, doctor login details. Okay, these are okay. So in our team, we're going to be like so 8 to 12 members, admin, developer. Okay, the client may be like from the USA or UK. Okay, so what we going to do, like what are the total visitors and so what is the doctor visiting to each patient how many times. Okay, so this is already we have done in the last class, just I'm recapping you. Okay, so we're going to have a reference from the client, then he going to discuss with manager, then admin going to talk with manager, then after he going to give the requirement to the architect, then architect going to do the data modeling like star schema and snowflake schema, then analyst, then developer. So these going to come in between, we have snowflake developer, dbt developer, and etl developer, and power BI team lead. Okay, so we need to know about star schema and snowflake schema. Okay, so here we have different types of data. So bulk data or live data. For incremental, we're going to use streams, and nowadays they are having like updated feature of dynamic tables. Okay, dynamic tables. After loading data, we're going to validate the data, deleting duplicate values. Okay, check the row count. Use the in Snowflake. oh, In Oracle, deleting duplicate values different. In Snowflake, we need to use the qualifier for deleting duplicate. Okay, then dbt it is like ELT2. So today we're going to see about completely what is snowflake and what is dbt. So we have done with the project, now we're going to see what is snowflake. Okay. So snowflake nothing is like a cloud based data warehouse, so where we can handle the large values of data and for analytic purpose. Okay, so here is snowflake is oltp or olap. So remember, Snowflake is OLAP. So OLTP is like day-to-day activities like bank, insert and delete, update. So daily withdrawal, daily deposit amount. So we're going to check in the OLTP system like Oracle. That is the example. So OLAP like Snowflake is a OLAP, and Redshift and BigQuery. So these are OLAP systems for to give output within the 1 month like that. But this is OLTP for activities. Remember it is. And pay as use model. And before that, it is a source model. No need to install anything. No need to install anything. Okay? So just we can create online account in Chrome. So where we go, we can use it. Okay. So with the username and password. That is SaaS model. No need to install any hardware or anything. And pay as use model. What is pay as use model? Suppose you are you want to go someplace. Okay, you going to book bike. or car, right? Like we have Rapido, okay, and Ola, Uber, we have it. Ola, Uber. These are services, right? Okay, so just you are booking for distance of 5 to 10 k, 5 to 10 kilometers. Okay, now you are not paying for that bike. You are not buying a bike, and you are not hiring that, okay, bike person who is like driver, rapid driver. Okay, you are not hiring him. You are not paying for the bike. You're going to pay for only the traveling distance. Okay, so the journey. So what you are traveling, you going to pay for only the traveling distance, like 10 kilometers and 5 kilometers or 50. That is pay as is pay as use one. Means what you use, we need to pay for that one. Suppose from Snowflake, I'm taking 2 TB. Here I'm using only 1 TB, and 1 TB I'm not using. It means 1 TB active. Okay, so 1 TB not active. It means here we need to pay for only this TB. So we need to pay for this. Okay, so no need to pay for this one. No payment. Okay, this is like pay as use model. Okay, in Snowflake. So many companies, many why they are using why Snowflake, because of first Snowflake. We have Snowflake and BigQuery or Redshift, okay? And these are competitors of Snowflake and BigQuery. Then here why Snowflake? Suppose here in Snowflake it's going to support multi cloud support. Here I will give the example. Okay. Here, see, Snowflake going to support cloud providers to the Snowflake AWS, Azure, Blob, and GCP. Okay, for Redshift, we have only AWS is 3 only. And for BigQuery, we have only GCP for data and cloud providers. So this is advantage the Snow. And we have zero copy. But in Redshift, no, there is no option like that. And in Bitcoin also no option. And here we have time travel to access the historical data. If any disaster happen, if any data is deleted from the database, we can access through time travel. This data we can access the time travel. Okay. So then next comes here no time travel. Okay. No time. Suppose warehouse multi-cluster warehouse here we have, and here no. Okay, and here no means uh, scale up instead of if you want to increase warehouse size within a second, so 1 second we can increase the warehouse, but Redshift it will we need to do the manually. Here also will take time, okay, but within a second we can increase the Snowflake. So this is these are main advantage. I will show the diagram. Okay. Here you can see multi-cloud. Here going to support AWS, Azure, GCP, but Redshift going to support only AWS only. Google BigQuery only GCP. So pricing model, pay for query, but this is we need to pay for node-based, but it's going to active always. Pay for query and Slack. Scaling instant within a second, auto stand manually. We need to resize. Okay, and this is like serverless auto scale. So cloning, here we have DB cloning without storage and storage cost. So here not okay. Data sharing, we can share the data in Snowflake live, but we can't in Redshift and Google BigQuery. And semi-structured data we can handle, okay, using variant, flat and ladder keys, and here limited. So good nested data. Okay, here concurrency multi-cluster warehouse. So here concurrent scaling and here good. So admin, if you want to set up anything, we need zero maintenance. Per year we need DBA, and it is also zero maintenance. Okay, compared to everything. So Snowflake is good, right? So that's why every user, because of in Snowflake, so in Snowflake we have admin, but no DBA role in the Snowflake, no DBA need in the Snowflake. Because need. So why? Because of everything done by the admin and manually by Snowflake on itself. No need separate DB. It's Snowflake. Okay. So these are features in the Snowflake wise. So yeah, the main thing is like Snowflake layers, or you can call we have three layers. One is like database storage layer and query layer, or query processing layer, or we can call compute layer. Then cloud services layer, cloud services layer. So these are like separate layers we have in the Snowflake. So this is one advantage. Suppose so in database storage layer, we're going the data going to store in this layer. So in the format of micro partition that we will discuss when we go with theory. So suppose I'm sharing data, it's having like so 5 TB data, okay. And query processing when we run the query like select star of table where ID equal to some 70,000 like that. Okay, the query going to run in this layer query. So cloud services layer. So suppose if you want to log into Snowflake account, you need username and password, right? So it's going to done in Slate, cloud services layer. Okay. So when you are running query in this compute layer or query processing layer, in compute layer, it won't affected by this storage layer. Means so we have separate layers, okay, in this Snowflake. So that's why if you run the query, it won't affected by this data 5 GB 5 TB data we have right in storage layer. So it won't affected by these data storage. So that is advantage in the Snowflake. Okay, so in cloud services like going to take away completely everything security or metadata optimization done in the in cloud services. So these three layers are separate layers. Separate layers. This is one advantage. Okay. So separate decoupled structure and separate layers. Okay. So this is one. And the features. So zero copy cloning. Okay. So we can clone the database schema and tables. I'll give you example. So I have table having your data like 5 GB data. So then we have storage cost. Okay. So using zero copy cloning feature, I'm cloning this table clone. Okay. So this table having same data. So how many, suppose we have like 5 million rows we have in that table. So this table also going to have the 5 million rows, but no storage cost, no storage. So this is one advantage as well. Okay, even we can clone the database and schemas and everything. So, but this clone table not going to have the storage and storage cost only. But still, we can access that. Even if you drop the this base table, still we can access the clone table. So this is one advantage in this one. And time travel feature. Time travel feature. So here, what is the exact time per picture? Two. So if any disorder or any wrong update in the table. So suppose I created one table today, sales data. So and after 2 months, after 1 month, okay, I deleted this table. This I drop this table. So sales data. So then after again 1 month, I need this sales data table. Okay. So first I have created sales data table. So after 1 month I drop the table sales data. Then again after 1 month I need this table sales data. So using the time travel, so we can access the historical data. Okay, we can access historical data. So up to 90 days we can access up to 90 days. So after that still we have fail safe. With that also we can recover the data that will done by the Snowflake company, there are Snowflake engineers, they're going to do it. Okay, the different process. Okay, totally we can recover 90 days. And So this is one advantage, and here we have like uh, handling incremental data. So or live data, live data. How to handle that? So bulk data. So using copy command, okay, we can handle directly. We can load into the target table, but live data. So here we have for live data. So snow pipe. So for continuous loading data, continuous data loading. So this is one advantage of Snowflake. So it is like serverless. Just we can do the setup. So whenever the data is loaded to the S3, so automatically this pipe going to trigger and it going to load into Snowflake target. So this is one advantage in the Snowflake and incremental. So I have one product table. So today I'm receiving one like so yeah example one name and the price some payment details, okay, and so place an example of giving place, okay. So these are things, okay, I like a1 this is like a product. So one a and the price like I'm giving $100 order place like anything like New York. Okay. So this is the order place. I have received so many rows I am going to receive. Again, I am going to receive few rows, millions of rows we are going to receive. So give like to speed and give like yeah, okay, two rows. This is first day I am going to receive. This for data for first day. Day one. Day one I am going to receive this data. And again come to day two. So day two I am receiving. I'm going to receive like three again C and 300 like so and again I'm going to receive like 4 and T and again some 400. Okay. So so this data I'm going to second day. So day two. But here what is happening? First day I'm creating one table. I'm going to receive this data. I'm going to insert this data into that table in the product table. So again, second day, I'm going to receive this data. So with this data, I'm going to receive again this first day data also. Okay. So first, totally. Okay. Again, I'm going to receive this data. So completely. I'm going to receive again same previous data also. I'm going to receive. So again, what I need to do? Suppose if I insert same data again into the target table, it's going to be already have these two records. So if I insert again this data, I'm going to receive this duplicate records, right? Duplicate records. So how to avoid this? So this is the day two. Again, day three, what is happening? I'm going to receive some new data. Then again, I'm going to receive this previous data. So complete. Again, I'm going to, this is again it going to be duplicate. So in real time, we're going to have the millions of rows, right? Not one, two, three, four rows. We're going to have the millions of rows. So in that scenario, how we going to handle this data? So usually in first day, so what we do, we create a table and we're going to insert this data. And again, second day, so we have duplicate data, right? So we will truncate the table and again we will insert this data. And okay, again third day, again we will truncate the table, again we will insert new data and this data. Suppose for day one it's taking like so 1 hour to insert data and example, and day two it's going to take 2 hours, right? For new data and old data. and day three also it going to take 3 hours. So what is happening here? We are paying, suppose example, $100 per time and everything. $100 we are paying. Then day two again we need to pay and $200. And day three again like it may be $400. It depends. An example I'm giving. So we'll take the time 1 hour, 2 hour, 3 hours. Taking the time 1 hour, 2 hours, it is going to take 4 hours, not 3 hours. So it's going to take the time and we need to pay for more, right? To avoid this, we have incremental. So incremental data loading. How are we going to do it? Okay. So that we going to incremental means so first day we will load this data. Okay. Second day, so we apply, we write like we create a stream table on the source table and source table. Then it's going to capture. It's going to insert only any new inserts and any updates and going to track the deleted records. Okay. So it's not going to insert again the same date. So using incremental, we can handle this. Okay. So before 1 month, companies, so they are using only this method. This method only they are using. Okay. Before 1 month back. Nowadays, from last 2 months, so we have one new feature in the Snowflake. Okay. So these are dynamic tables. So directly when we are receiving from source, so we can create a dynamic table on the source table. That it's going to capture this data. It's going to push unique. It's going to generate find like transformations. Direct transformations. So these data directly used by the reporting team. Okay, reporting team. So this is one approach. Okay, instead of incremental, we also have the dynamic tables. Nowadays, they are using from last 2 months in the projects. So and also we have like iceberg tables, okay, and usually table types are like permanent. Okay. So permanent table we have, and again we have like temporary, and then we have transit. Okay. So transient tables we have. These are we going how to handle data. Okay. And the different types of loads we have bulk, continuous, and incremental process. And we need to know about discuss about like SCDs. Okay. Slowly change your dimension. So in our project, we're going to implement SC2, SC type 2, and SCD type 1 we're going to implement in the Snowflake project. Okay, most of them we're going to implement. Okay, so this is like completely Snowflake. Okay, basic, not in depth. Good features in the Snowflake, and we also have the data sharing in the Snowflake, live data sharing. So how we going to share data? Okay, suppose I have Snowflake account. Okay, and so another person having Snowflake account, then we can share direct share, create share and I can share. But I have a Snowflake account, but the receiver, okay, who is the person, other person, he don't have the Snowflake account, he do not have it, so have it. So how it going to be? So for that, we need to create some other things in that Snowflake. Okay, this is a type 2 data share. So the third one is in the Snowflake market directly we can share. Okay, so we are sharing live data. We can share in the Snowflake, and so security like the data masking. So data masking it means like dynamically we can mask the data. Dynamically we can mask the data. Suppose see, suppose you want to there is a table. In the table we have one is like a UK column and one is like a USA column. It may be Australian different. So I want to share same table with USA and UK, but there is one thing. Okay, the USA people no need to see about the UK column, and UK people no need to see about USA column. So in that we need to hide the data, and we need to write some case statement. Okay, so that is we can handle the data dynamically. We can mask the data. master data. So we have, suppose we have manager, and we have analyst, and we have admin. Yeah. So manager, the manager means like HR manager. So there is a table having like any number like SSN, like seat or anything, not SSN exactly. So here we need to hide the sensitive data, right? So manager need to see only the like this. Okay, you can see like this. And this counts the complete data. You need to see data like this one. And admin, you can see complete data. So full data access you have because of the account admin. Okay. So the way of masking you need to. Okay, admin need to see everything, and manager you can see only partially data visible. But for analyst, completely going to be hide. Okay. So these data we going to hide, and here suppose department wise. Okay, this is row wise, and this is column wise. So department wise, suppose we have HR department. Okay, and so okay, HR department. Okay, and we have so AR department. Okay, BR department. We have separate different environments. Okay, department. Suppose when HR runs query on the table, you're going to see about only details about who are in the HR department. So when AI runs the query, we're going to see only who are in the AI department, like that of BR department. Okay. So they need to see only what the data they can see only. It's going to encrypt it. Okay. So that is like we are also going to have like PI data. Okay. So these are we can handle. Okay, not only this. Okay. I'll show you this one. So we'll go with the project flow, intro, and theory. Who going to work with, like how many members in the team, what is the project. So role-based access control. It means like suppose you have same table, right? Okay, someone going to create the database schema, and someone going to create the tables. If I go to if I open my laptop, I can't access everything. I have only a few databases I can access. So that is like role-based access control. And out of like data modeling, so we're going to receive multiple tables, right? Okay, I will show that. So these are the data. Okay, we are not going to do with work like 10 or 20 records. We're going to handle the so more than 2 lakhs records in the table. More than 2 lakhs. So we're going to receive different types. Okay, in reality, we're going to have like more than 100 tables we're going to have. So in each table, we're going to have the more than 100 columns also. Okay. So these data, how we going to handle, and so what is your approach like a star schema, snowflake schema, and what are the fact tables and dimension tables. So data modeling, it will be done by the architect. So that we're going to discuss. Okay, star schema and snowflake schema. Okay. So this is a star schema having fact table and surrounded by the dimension tables. So fact table going to have only numeric data, dimension table going to have the description data. Okay, this is star schema, and this is snowflake schema, fact table, dimension tables, and uh, sub-dimension tables. Sub-dimension. Okay, so here we have numeric data and description data. Here some region and category data. Okay, this is snowflake schema. So first the architect is going to decide. Okay, so which we need to follow, okay, which schema. So we that we're going to some data modeling concept and OLTP overlap and what is the normalization, denormalization. Okay, so theory. So first, how the way of learning. First, we need to go with theory, and then practical and real-time use case. So this is way of learning. If you go this, okay, you can learn anything like easy. Okay, this is okay. Then see. So data modeling and star schema snowflake schema we're going to discuss. Okay, this is our tech, but we can. So stage. Okay, we're going to discuss the stages. So exactly what is a stage? What is stage? Okay. So directly we can't load data SC to Snowflake. We can't load it directly. So yes. So suppose give simple example. So there is person living in New York. Okay, okay, and one person living in Madhu. Okay. So this is like A person living in the New York and B person living in the Hyderabad. So here A can't move to B place and B can't move to A place. Both are in a different place, but A don't have B don't have the visa and A don't have some they have some restriction. Can't move to the Hyderabad. So what we do? So there is like a B person, okay, and they having mobile phone. He need to give to the B. So what he will do? He will give this mobile phone to C, and the C can travel to both places. He have visa and everything. So then C moves to B and they give mobile phone to B. It's like this here. So A like CSV file, CSV file. Then B's target table, and C is like a stage. So directly we can't load into the Snowflake. In between we need stage. So see like intermediate. So this CSV file we need to push into the stage. After that, using copy command, we need to load into the this Snowflake targeting. So this is the stages. We have different types of stages like internal stages. So internal like user table name and internal stages. So these are when we are loading data on premises Snowflake or local Snowflake, we going to use. And external stages are AWS, Azure, GCP. Those are external stages. Okay, we're going to discuss about so stages like internal stages and external stages. We're going to discuss about both. Okay, so here we're going to use put and get comments how they going to work. Okay, how we need to access Snowflake to command prompt. Okay, we're going to discuss everything. Okay, then copy command. Okay, here copy command is like data loading. So from CS file we include target, right? Okay, so simply running copy command, you can load the data, that's fine, but how, right? So suppose so same file again you want to load, and so there is multiple files in the S3 bucket, right? How you want to load only specific file, and you have some size limit, and you have some differences. So like that, we going with copy command options. So those are we going to discuss. So not only just loading data, that thing you can load simply from anything, but some advanced level. How are you going to load in different types? There are different files. How are you going to create a file format? Those things. And here, copy command option like that. Force, Spark. Okay, those are we. And for continuous data, we have the Snowpipe, live data. So if you want to generate the live reports, we have. Then, so this is fine, loading copy command and some in-depth of copy command options. Then we have error data handle. How you going to handle if suppose you have a table and here you have created. So this is name string, okay, the string. But you are loading data, okay, that is number in the data. Number your numeric data is if you are having CSV, how to go and handle and null values, okay, and column mismatch. Suppose you have in CSV file three columns and in table you have only two columns. How you going to do column mismatch and so null values done by null value. So those are different and error data, double quotes we have in the data sometimes, double quotes. So and these you how you going to handle this. So for that we're going to use the this error handling. Okay, error handling and throw data into the target. So we can handle errors after that, or we can load this error data into the error table that we're going to discuss. Okay. So these are that we're going to discuss how to handle error data. These things we need to push under statically and dynamically how we can mean it. Statically we can do it, and dynamically we want to handle error data. We need to use the store procedures. Okay, so that we're going to discuss in the class. Okay, so this is error data handling in the Snowflake, and after that, so after that loading data, what we'll do, we have data, so we need to maintain the data consistency. For that we're going to use the for backup data. So we use zero copy program. And so I am one employee in the I'm one teammate. Okay, So there is some other guys in the team, right? So they want to work on same database. So in that scenario, so they will clone the data. If they can same table, okay? Database. So person working, we have something and person two working and person three working. Okay? So here, how we going to copy this data using zero copy cloning. So without storage and storage card, okay, person one going to clone and you can use person two going to use person on same database on different names. We need to use zero copy cloning. We need to clone the data. So this is one advantage in Snowflake. One advantage. So next, how we going to do? Next one is like so this zero copy cloning time travel. If any data is deleted and when it is added, we can go into recover data. So we can go into recover that. So those data using time travel feature and we have fail safe also. It will fail safe is done by the Snowflake team. We need to request the we need to raise the complaint. They need to recover for us. Okay. So table types, permanent tables, so temporary transfer. Those are basic tables we know already. So, but we have advanced tables like hybrid tables, dynamic tables, iceberg tables. So those also advanced feature we're going to discuss and types of loads, bulk, continuous streams. Okay, I have explained right incremental data loading. So task also are very important. Create task name and whereas name or time 1 minute. So that is simple thing, right? So, but we have in-depth concept like a grandparent child task. Suppose if you are running any task, it going to depend on another task. Those things are discussed, okay? And slowly change the dimensions. We need to know about more about this one. So type 2 and type 1 we going to use. So this is about slowly change dimension we going to discuss. Okay. So look guys, so there is only 1 minute, okay? So please rejoin with the same link. Rejoin. I'm going to end the meeting. Rejoin now. Rejoin now. Same. Same now. There is only 1 minute. So here we're going to discuss about slowly change the dimensions. So weaves, okay, we have in Snowflake like standard weaves, metalized weaves, and secure weaves, and also we have secure metalized weaves. Okay, virtual table how to create weaves and what are their limitations and what is the connection between joins and weaves. Okay, when we create a metalized weaves and join the two tables. Okay, what are the issues we going to face those and we have some input function and also we have that UDF, okay, user defined function. Those we going to discuss. Store procedures, okay. So store is nothing but like so in our home we cook food and we put in refrigerator, right? And after that, when we need we going to use those food, right? Okay, like that, we're going to create so procedures and we're going to use it. And again, so we have dynamic tables and as well as data masking policy, so data sharing and pricing, billing, so monitoring and catch tagging. Okay, some other advanced topics we're going to discuss. Okay, partner connect, pagination, storage metrics, performance tuning in Snowflake. These are provide the nodes and we will discuss. Okay, and JSON data handling. Okay, some real-time data. Okay, these we're going to discuss. Okay. So these are our main Snowflake concept, and we're going to cover everything, not only theory and practical, behind the limit. Okay, how the data going to be stored in the Snowflake? What is the architecture? So project architecture, everything we're going to discuss classes. So this is about Snowflake, and come to about DBT. So what is DBT? So data build tool. It is the like ELT tool like extract and load and transform data. Extract, load and transform data. This we going to suppose. So what is DBT exactly? So we can do transformations in the Snowflake. So why DBT? So we can do transformation there, but still we can do more, and we have reusable codes in the DBT and the lineage data we have, documentation we have, and the CI/CD we have, continuous integration and a continuous deployment we have. These are we have in the DBT and still okay. So there is like a DBT job scheduler, DBT cloud scheduler. So why is DBT means? I'll give simple examples. There is a table A and a table B and a table C. Here we have A to B chain condition and B to C chain condition. The requirement is need to chain A to B and B to C, which is the requirement. So in Snowflake, we have like this type ABC three tables, these chain conditions. So you can't use A to B and B to C directly. So instead of what you do, again, you will write the entire code A to B and B to C and C. Directly, he going to write the entire code again to James. So, but in DBT, what you going to do, you have already A to B, right? You're going to give a name like D as a model and B to C, how right? You're going to give name like E, then directly going to change within a minute. D to E going to Jane A to B to C. If this is advantage in the what DBT, okay. Suppose mathematics formulas, right? Okay. So we want to create formulas or macros, not a formula exactly. So macros, okay. You're going to create macros in one folder. So after creating macros, wherever you need those macros, you can use the model. So model is nothing but it is like SQL code only. SQL code model is okay. Model is SQL code only. SQL model SQL code. Okay. So we can create okay models and we can create macros. So wherever you need macros, you can use in the models. Macros is nothing but suppose there is a product. If you want to find out percentage on that tax percentage and discount percentage, okay, that is going to apply into the model. Okay, so these are okay. So in DBT we have staging environment and intermediate environment layer and mart layer. Or these are main in the DBT. In Snowflake, whatever you have, so raw layer, staging layer, curator layer. Those are in the Snowflake. But in DBT we have staging, intermediate layer, and so mart layer. So these are going to work with these layers. Okay. So what are the models? Okay. So after loading data first, so we will see about the DBT service. So in DBT we have like models. Models are SQL codes and tests. So after loading data into the Snowflake, okay, you directly first we need to create the models in the DBT, and after that, so we need to write the test in the testing on that data. What are the models we created? Like we have unique test, Norton test, and accepted values test we have in the DBT. Okay. So this thing we have okay, test in the DBT. Okay. So next one, like what we have like so metalizations. We have metalization like table. Okay, we increment the advanced incremental per data and FML. Okay, FML just we have in the DBT, but it won't create a viewer table in the Snowflake. So when we need, we can use it. Okay, that is FML models. Okay, we're going to discuss about metalizations and models. So then we have like so and seeds are like CS files we can use or create. Those are uh, permanent tables in the Snowflake seeds. And cloud features we're going to discuss. So those things and Ginger templates we're going to use. Cloud feature nothing but So in core DBT core we have some features, and the DBT cloud have some more features like scheduling and everything. So those features we're going to discuss. So we're going to use also Jinja templates and everything. Okay, Jinja. Okay. So usual for the statement, expressions here and the comments we're going to use. So these are so in if you are creating any model on the if else and loop data, we go and handle Jinja also. We can again load macros done right to work like formula snapshots to access the historical data. Okay, and hooks concept, we hook and post hook. So when we are running the model, what is happening before and what is happening after running the model? Before running the model, what is happening? And after running the model, so what is happening that we're going to discuss snapshot and hooks calls, that is going to be hooks, not snapshots only for historical data. And this hooks for this incremental materialization, incremental process, snapshots, historical data, and hooks. So when we run the model, what is happening before running the model and what is happening after the model when it started. So when it's the end, what is happening start point and end point. So analysis folder we have in the DBT. So whenever we need, okay, we can create some files. We will put in the analysis folder, but it won't create. We were table in the Snowflake for practice purpose only. For analyzing data when we having, okay, and to save the cost. Packages. Suppose you are doing any test, it's not working in the DBT. So what do you do? So we go DBT utilities websites, DBT utilities, right? DBT utilities. So these packages we have in the DBT. So okay, these packages we need to install. Suppose you are using the now at least one this. Okay, you need to copy this code. Then you need to install and you can use it. Okay, this is the code. So this is good in the DBT. Whatever you need, you're going to use it. The three packages. Okay, and we have continuous integration and continuous deployment. Suppose we have move data dev to test to production. So from the DBT, we can schedule, okay, everything, jobs, running the models, testing, documentation, everything we have in the DBT. So that we're going to discuss. Okay. So this is complete. Okay, and AWS S3 services and ADF block we're going to discuss. Okay. So what I means simply attending my classes, you're going to get it like minimum 5 years of experience. I give, it means I will give entire you to practice that. You will get minimum. Okay. So 5 years of experience on the your real time experience. Okay, you have on the Snowflake and take it. Okay. So these are I'm going to teach. Okay. So as of now, anybody having your doubts regarding this session, right? Okay. So fine. Tomorrow we will connect same again 8 a.m. Okay.